Hi, I'm Wyatt Manning,
And I'm Steph Fry.
and then this is our final project, a Porch Pirate radar. So our problem statement that we came up with is when you're ordering a package, the whole process, it's great, but some things, creature comfort that we have is ordering packages. Now that we have that, with everything good, something bad has to come from it, which is Porch Pirates. Porch Pirates being the people that see the package on your front doorstep, decide, hey, I want that, and take it. This device here is what we came up with to try to hinder that to the best of our ability and allow it to stop happening. So we'll plug it in here. It's a little loud, so we're not going to run it during the whole thing. So basically all it does is this spins, and the sensor up here is constantly scanning. This would be placed outside of the door on someone's front porch, and someone's door. You can hear it kind of there right now. In this form, it would be obviously in another unit, but obviously it's not like that here. This is just a prototype. So it would be on the front doorstep scanning as you have a package or whatever on your front doorstep. If someone, a porch pirate, decides, hey, I want someone's package, comes up, bam.
Yeah.
That alarm will start going off. Obviously, this alarm isn't the loudest thing in the world, but in the real world, it'd probably be a little bit louder than that. And then the light that's blinking, you could have a flashing light if you'd like, but mainly what we want that to do is simulate a signal being sent to authorities or a telephone that could be yours to alert you that someone's stealing your package and alert the people that someone's stealing your package. So that's the functionality of the prototype. I'm gonna unplug it here so we can move on and not have loud buzzing noises going on, but I'm gonna hand it over to Seth for some more stuff.
All right, so for our setup, most of it is just initializing all of our pins as we do with our Arduino projects, setting up comments for our variables, so making our variables something short, easy to understand by everyone. For example, we have like trigger pins, our stepper motor pins, our current step, our direction, so that our radar doesn't spin all the way. We only have it set to a 180 functionality. And yeah, just setting up each pin number and variable name.
So the radar itself, this is our code snippet for the radar itself. This is just going over how to take into the direction that we just initialized, allowing it to read that, send it to the motor, so the motor only knows to spin within those limits, allowing it to be a radar and scan. And then under that is the portion is if this photosensor sees something, detects something in its range, that'll send the signal to the LED and the buzzer. The buzzer code is on the next slide, but mainly this is the one for the LED, saying to deter them and allow them to know that they've been caught unnecessarily.
And then we have our Be Gone code, which is what triggers our buzzer to scare away our perpetrator. Oftentimes loud noises are a very easy way to scare anyone away, especially someone who's just looking to get an easy package. So a loud noise going off with something as simple as this, with whenever the sensor's triggered, the buzzer will activate, can be a good method and deterrent for porch pirates.
And then here's a flow chart, basically kind of just visualizing how the code works. It's a little blurry, unfortunately. Basically, top one starts, initializes our variables, initializes our maximum angle for our motor. Then we configure our pins for our LED, our motor, and our buzzer. Then here we have it start to spin, it has the sensor start to spin with the motor. Down here is taking readings of the distance from the motor. And then on the side here is where it prints it out to the serial print monitor. Down below that is where it's checking to see if anything's within that distance that you set. If no, it'll just continue to run it over and over and over again, which comes back up here. If yes, then that's gonna trigger the Be Gone code, which triggers our buzzer, and the LED code, which starts blinking. Then under that, that's once the pirate has backed away from that distance, it'll shut off, and that'll go back to normal. And then the code will continue to run until it's turned off, which comes back up to here, which then runs this whole process over and over again.
And then here we have our circuit diagram. So, so up here we have our buzzer, which is simply hooked up to our pin 8 and to a ground cable here. Here we have our ultrasonic sensor, which we have it going to power here, have our ground going here, connecting up here, and then our trig and echo pins, which go to pins 11 and 12 respectively. Then here we have our stepper motor, which hooks up to our stepper motor driver board with its power and its initialization pins hooking up here. And then from our stepper motor driver board, we have our ground, which hooks up with the same ground network that our buzzer and ultrasonic sensor have, along with the power, which hooks up with the same 5-volt power that our ultrasonic sensor has. And then we have our IN pins, which hook up to pins 2, 3, 4, and 5, respectively from 1, 2, 3, 4. And we have our LED down here, which is hooked up to pin number 9 with a 220 ohm resistor, and then hooks up to the ground with the same network as the buzzer, the driver board, and the ultrasonic sensor. And that's our circuit diagram.
Thank you so much.